Can you automate front-end engineering using AI? That is the question which this research work attempts to answer. So this is known as Design2Code. Basically, can you replace a front-end engineer with AI? So this is a research work from researchers at Stanford, Georgia Tech, Microsoft, and DeepMind. So what they call as Design2Code task is nothing but, given a visual design, can a multimodal LLM convert it into code implementations directly? That is what is their Design2Code task. So they created a benchmark of 484 real world web pages as test cases. They also developed a set of automatic evaluation metrics to assess how well current multimodal LLMs can generate the code implementations that can directly render into the given reference web pages, given the screenshots as input. So they also developed a set of multimodal prompting methods, okay, and they use GPT-4 Vision and Gemini Vision Pro to show the effectiveness of these multimodal prompting methods. They also fine-tune an open source Design2Code 18 billion model that can successfully match the performance of Gemini Pro Vision. This is quite interesting work. And what is the outcome of this work? The outcome of this work is that GPT-4 Vision is the clear winner based on human evaluation and automatic metrics, where annotators think GPT-4 Vision generated pages can replace the original reference web pages in 49% of cases in terms of visual appearance and content. And perhaps surprisingly, this is separate to the first case. If you look at the GPT-4 generated web pages alone, in 64% of cases, GPT-4V generated web pages are considered better than even the original reference web pages. Okay, so this is quite an interesting work. This also shows the huge amount of gap which is there in these multimodal LLMs on how they can generate reference code compared to a human front-end engineer. Okay, but this is interesting that in 64% of cases, GPT-4V's Vision's generated web pages are better than the original reference web pages. Okay, so this is quite an interesting work. We can have a quick look at test set examples. So the previous benchmark was website Hugging Face, from Hugging Face. In this benchmark, you had websites like these, which you can see over here, right? Let me zoom in a bit. Okay, you had these web pages like this. In their benchmark, these are the web pages which are present currently. Okay, so you have a variety of web pages over here. So they have this paper where they talk about how this web page data set was created. Right, so these are based on real world web pages, whereas website was based on synthetically generated web pages. Okay, this particular data set is based on real web pages. But then there are some caveats over here, like the web pages are made standalone web pages by removing all things like script, audio, iframe, map, SVG tags, and removing all link tags. Okay, so they want the code to be generated is for a standalone web page. It's not the complete web page with all your other elements. Okay, so it's more of a static web page and it's not dynamic web page. Okay, so the other techniques of dataset creation, they have put it over here. They also created metrics which look at high level visual similarity between the reference page image and the web page which has been generated, the code for the web page which has been generated. And they also have low level element matching like block match, text, position, color, etc. So based on these different dimensions, they compare all the benchmark models. Okay, and then this is how they compare it, and if you look at it, they say the best is GPT-4 Vision with a technique called as self-revision for the prompts. Okay, and what is this self-revision for prompts? Basically for prompting, okay, they created this three kinds of scenarios. The first is direct prompt for the multimodal model, okay, like GPT-4 Vision or Gemini Pro Vision. So direct prompting is this. You give a following instruction like this. You are an expert web developer who specializes in HTML and CSS. User will provide you with a screenshot of web page. You need to generate the code. Other details are present over here. Okay, respond with the content of the HTML plus CSS file. Then the next technique is something called text augmented prompting. So with the above prompt, what they do is that they will actually also give as part of the instruction the text of the screenshot of the image, basically screenshot image of the website plus text which is present in the website. Okay, so that is what is your text augmented prompting. Then they created a self revision prompting technique which is inspired by other works. So here the idea is that they provide the following as input: the screenshot of the input web page, okay, the screenshot of the generated web page from text augmented prompting from the previous prompting technique, the generated code from the previous prompt technique, okay, generated code from text augmented prompting as the initial solution, and ask the model to improve the generated implementation code so that the result can look closer to the reference web page. That is what they have done. Okay, so this is the self revision prompting, and with this technique they could get very good results. Okay, so here they talk about the results. Where is the results? Let me come to that. Yeah, here they talk about the results based on these automatic metrics. They also did a human evaluation on the generated pages. So they asked human annotators to do that evaluation, where they did a pairwise model comparison and they did direct assessment. Okay, so based on that, they came to these two assessment from two perspectives. One is, can the AI generated web page replace the original web page? They say 49% of the AI generated web pages are considered exchangeable with the reference web pages. The second is the reference web page or AI generation better? Here, web pages generated by GPT-4 Vision are preferred in 64% of the cases. They are considered to be better than original reference web pages. So this is based on human evaluation, these two statements. Okay, and they also do an automatic evaluation versus human evaluation to see what are the differences, and there are some differences in terms of the automatic metrics and human metrics, and they say that humans usually pay more attention to high level visual effects and the layout rather than the detailed content, reflecting the top down processing of humans. Okay, so in some cases what will happen is that the human metrics would be better but the automatic metrics may be poor, and vice versa. That could be because of this reason. That is what they are saying over here. So this is an interesting work about how far are we from automating front end engineering using AI. Yes, there are caveats in this paper. Newer models will come, better models will come. Probably you need to evaluate it again. But yes, we are far from automating front end engineering using AI. And this is basically on static pages. Dynamic web pages are not even considered currently. Long complex web pages are not even considered currently. So yeah, all those limitations are still present, right? So this is an interesting work. I'll be putting the link to this web page in the description of the video. If you like the video, please like, share, subscribe to the channel. See you in another video.